Discuss solution of a particular class of partial differential equation known as Lagrange's partial differential equation. This is a linear partial differential equation. That is, this is a partial differential equation of first order. And here, the format of Lagrange's partial differential equation is given by Pp plus Qq equals R, where capital P, capital Q and capital R are functions of variables x, y, z. X and y are independent variables and z is a function on x and y. Here, small letter p is the partial derivative dou z by dou x and small letter q is the partial derivative dou z by dou y. To solve such kind of partial differential equations, the steps followed are: first step, frame the subsidiary equation or the auxiliary equation for the given partial differential equation. Whenever you find a Lagrange's partial differential equation, the auxiliary equation is given by dx by capital P equals dy by capital Q equals dz by capital R. R is the function occurring in the RHS of the given equation, Pp plus Qq equals R. Capital P is the function occurring along with the partial derivative dou z by dou x. Capital Q is the partial derivative. Capital Q is the function occurring along with the partial derivative dou z by dou y. And capital R is the function which does not occur along with dou z by dou x and dou z by dou y. We compare any two of these ratios, either first two ratios or last two ratios or the first and third ratios accordingly, and we find out the solutions. These solutions, if we represent as u equals c1 and v equals c2, that is, solving any two of the given ratios, when we arrive at solution, if we call the solutions as u equals c1 and v equals c2, we can write the complete solution in the format phi of uv equals 0 or u equals function of v. The complete solution has to be written in this format, that is, function of the first solution comma second solution equals 0, or the first solution equals function of second solution. This is the format of writing complete solution for Lagrange's partial differential equation. Let's look at an example. Solve y square z by x p plus x z q equals y square. Notice that this is Lagrange's form of partial differential equation. If we multiply the complete equation using x, you obtain y square z p plus x square z q equals y square x. Now we will write the auxiliary equation, which is given by dx by p equals dy by q equals dz by r. We know that capital P is the function y square z, capital Q is the function x square z, and capital R is the function y square x. Capital Q is the function occurring along with the partial derivative q, small letter q, and capital P is the function occurring along with the partial derivative small letter p. This is capital P, this is capital Q, and this is capital R. We write the auxiliary equation. If we compare the first two ratios of this auxiliary equation, notice that z is common to both denominators and it can be cancelled. Now, when we group x square along with dx and y square along with dy, we obtain this equation. When we integrate both sides, we obtain x cube by 3 equals y cube by 3 plus constant of integration. You bring both the terms containing x and y to LHS and we have x cube minus y cube equals 3 times c1. 3 times c1 is yet another constant which can be considered as capital C. So you can write the solution obtained by comparing first two ratios is u equals x cube minus y cube equals constant of integration C. Now comparing the first and third ratio, we have y square common to both the denominators and it can be cancelled. After that, you group x along with dx and z along with dz. So you obtain this equation and now you integrate both sides. You obtain x square by 2 equals z square by 2 plus c2, which can be written as x square minus z square equals 2 times c2. 2 times c2 can be considered as another constant c dash. So you get x square minus z square equals c dash, where v equals x square minus z square. Equations 1 and 2 are representing the solutions. Since we have obtained u and v, we can now write the complete solution. The complete solution is written as per the format u equals function of v, that is x cube minus y cube equals f of x square minus z square, or we can write phi of uv equals 0. The representation phi of uv equals 0 can be written as phi of x cube minus y cube comma x square minus z square equals 0.